Good to see you back. We are well advanced into the semester. Today we have urban science, a conversation. Before and after this conversation, you will hear a lot of examples, definitions, and the conversation will be with Artem Chirkin, one of our PhD students, who you will meet in a minute. There you are. We have come quite a long way already, just after urban research the last time, now into urban science, and hopefully finding out what that is. Here we can see the story so far. Many things you learned already. Remember the smart houses, something very practical. Then the methods and tools for urban design, more abstract. Then the stocks and flows as the fundamental aspects of and concepts of urban models. Then finally the metrics of smart cities last week. And today is the citizen design science that could close the gap between science, urban science, and the city itself. But let's see if we get there, that far. So this is the content. We start with definitions again, then we have this conversation, then we give you examples if it's still time enough, and finally some conclusions. The definition of science, all of you know, it's quite straightforward. It's the knowledge about the structure and behavior of the natural and physical world based on facts that you can prove, for example, by experiments. That's definition from the Oxford Dictionary. If you want to go into urban science, you could make the analogy and say it's the knowledge about the structure and behavior of an urban system based on facts that you can prove, for example, by theory, experiments, and simulation. Of course, you cannot prove it by theory, and you cannot prove it by simulation. You cannot prove it by experiments because it's far too complex. You cannot make a reduction of a city to one number or one point, but you can use the analogy to the definition of science. As we will see in the conclusion, all these attempts in the past, since the 1960s, to make urban science really successful have not been successful entirely, and we will also see why not. Just a quick question. Any one of you has dealt with urban science in the past? Has a formal education in urban science? No? In the future, there will be programs about urban science. I'm pretty sure about this. There were actually in the past. They went away, and I'm sure they come again. The two words that I highlighted here, structure and behavior, they're very crucial for all kinds of sciences. So the structure, you can imagine it's what holds everything together, either by forces or by physical structure. And the behavior, that is that which is really quite difficult to understand sometimes. This is the interaction between the structural elements and other structural elements. In the city, that is the interaction between all the parts of this complex system. And in that sense, exploring the structure of a city, we want to revisit that short definition I gave you of the urban model last time by Christopher Alexander from his book, A City is Not a Tree. And now you will see why this is related to urban science. He writes about the similarities between a city and living structure, but he says it's not the same. So the tree of his title is not a green tree with leaves, it's the name of an abstract structure. So abstract structure is the thing he tries to use to understand the city. And he contrasts it with another more complex abstract structure called the semilattice, but this is also already very specific. Then in order to relate these abstract structures, he must make a simple distinction. Then he defines those two types of cities that he can imagine, the natural cities and the artificial cities, and he gives examples of those. And finally, he says both the tree, this one abstract structure, and the semilattice are ways of thinking about a large collection of many small systems, and it goes to make up a large and complex system. So the complex system, this is the topic of the next lecture, and he has packed it all into the short definition already. And the structures of sets, that connects it, of course, to mathematics, where he can start to operate on these abstract structures. So still we are on the aspect of structure, and he takes the example of the village that's made up of a number of separate closed groups. So the structure is a set of groups. Then he goes into the social structure, and this is interesting because the social structure is obviously connected to the social, that means to the people, to humans. And there are all these semi-stable structures that you have in cities, in buildings, and so on, become very dynamic. That's why the behavior becomes very important here. But the social structure, he says, is utterly different today from these traditional structures, and therefore he proposes to make a semi-lattice of that. But again, if you show that to people or to you, in the beginning you probably wouldn't have thought that has anything to do with a city or your area of study this semester. But this is the abstraction, the abstract structure that he's talking about, which he then represents as such drawings of the tree and the semi-lattice. That was the structural aspect. Remember, in the definition of science or urban science, the other important word is behavior. And here we go into the behavior examples. One of the gentlemen or the authors that I mentioned to you at the beginning of the course, Anthony Townsend, he wrote this book on smart cities, which is the subtitle, has the subtitle Big Data, Civic Hackers and the Quest for a New Utopia. He has written many things about smart cities and the development of smart cities in the past. And he gives a rundown of all the centers that exist in the world that deal with smart cities. So this is an excerpt from an article from his, not from this book, but from an article of his. And I picked out this one because this is a very important center, the Center for Advanced Spatial Analysis, so-called CASA, at the University College London. It's not new, it's 2 decades old, as you can see, but it's still very important because Michael Beatty is one of the real fathers of urban science, and his book that he has published recently on smart cities and urban science is really a standard work as it's described here. It has developed a strong partnership with the Greater London Authority, most notably with the Transport London, one of the GLA's 3 main units. This is also typical. These urban science centers, they need to connect always to reality in some way. So they connect to city authorities, mostly not to country authorities, but to city authorities that know most about the reality and the specifics of their area of studies. And transportation is always a very, very important area of studies, as we could see from the exercises that you handed in great numbers already. Thank you very much. At this point, another question. CASA, does somebody know this? Has somebody a friend at CASA? Does somebody know where it is? Has somebody visited it already? No? You have? You know it, at least. Yes. Okay. So it's really a very important center. It's been around for 20 years, and still very good new research is coming out of this quite often. The other center that Townsend describes is the Future Cities Laboratory in Singapore. That's the quote. For instance, the heads of ETA's Future Cities Lab in Singapore, arguably the largest urban science center by far, is a plant ecologist who started his career in the rainforest, Peter Edwards, who's my successor in Singapore in this position of director of the Future Cities Lab and the ETH Center. And this is quite interesting because it's a new center, relatively new center, about 5 years old, and it has grown very, very big very quickly. And I know very much about it. Also, other people in the chair know a lot about it because we have founded it, and this is the content of our work in the recent years and also in the next 5 years. And therefore, we have a real lab where we try to do real urban science, and therefore this is very close to our area of competence. Here is a list of how these centers emerged. So, as I said, already in the 1960s, which would be out there on the balcony, it started with urban science, a loose definition or a rough definition of urban science, and then it took a few years until the first centers for urban science were founded, and this Center for Advanced Spatial Analysis, this CASA, in 1995, very important one. Then almost 10 years later, the Sensible Cities Lab in MIT. Anyone knows that? Come on, you must know this. You must know this. These are, like little light towers around the world where this urban research is being done. So just remember the names and go to the web and look it up. So that's another one, the Sensible City Lab. Then the Urban Scaling Working Group at the Santa Fe Institute. Santa Fe Institute, any takers? Anyone heard of it? Oh, no. Okay, this is another very important institute, as you can see, about 10 years old, this working group, and that started to deal with cities as complex systems, to look at cities as complex systems. And it's really a very, very famous institute. If you watch TED Talks, for example, you can see TED Talks from Jeffrey West, who was the director of the Santa Fe Institute, talking on cities, giving you an introduction to this field. Then it goes into the Urban Informatics Research Lab in Queensland University of Technology, 2006. And then 2010, this is our Future Cities Lab at the ETH Singapore and Zurich in 2010. Mr. Townsend is very complete in his description, except for the descriptions of the titles. It's not quite precise. And when I read over it, it only jumps into my mind. So I hope the other titles are correct. Then we have in the Boston Area Research Initiative by Harvard University in 2011, 2012, and now you see a whole bunch of others coming up who are doing the same thing. Always wanting to study urban science, how the city works, because that is going to be one of the biggest research areas in the coming years and decades. If you come from a university, a top 10 university, top 20 university, top 30, whatever, top 100 university, and you look at the strategic plan of your university, you will find urbanism and urban questions and urban science suddenly on the top of the list, or even in the top, at least in the top 10 of the strategic areas. Something that would have been unthinkable 10 years ago. So the city as a subject of urban science or of science is moving up in the agenda of all universities. The example that you saw 2 lectures ago, the stocks and flow, this is a very good example for structure and behavior. Now, this is a combination of urban structure and urban behavior. And that was the diagram I gave you. Pick any one of those and make up your mind what is structure, what is behavior, or is it a combination of the two? What do you think? Is there any one of the fields here, one of these stocks and flows, that is purely structure? Is there only one that's purely structure? Take a guess. Your guess is right. There is none. They always have a combination of structure and behavior. You can pick anyone. If you look at these stocks and flows on the left, space, energy, materials, people, capital, water, information. You cannot imagine one of them just being structure or just being behavior. They always have the two components. And even more, then it comes in these applied areas where you apply stocks and flows of energy to low exergy buildings. Of course, you have stocks and you have flows. Stocks like an expression for structure, and flows like an expression for behavior. So you have it already combined in the title, structure and behavior as a basis for urban science. So that is one example. Another one is livability. Livability was the big theme of the last semester, and we had experts from all over the world talking about livability. And one of the first explanations of livability was this one here by Stephen Kearns, the director of the Singapore ETH Future Cities Lab at the moment. And he gave us this triangle, which of course he quoted from another source. But you have here these different levels: the physiological level, the safety level, love and belonging level, esteem, and self-actualization. So these are the different parts of the triangles that build on top of each other in order to make any environment or a city, a house, or even a personal environment livable. And you can see at the bottom you have the very basic requirements, the physiological requirements, the breathing, the food, the water, the sex, the sleep. Everything is there that we need for every day and survival. Then the safety, then love, belonging with friendship, family, then esteem, respect by others, and self-esteem and confidence, and finally the self-actualization, what is seen as very important at the highest part of the livability, with acceptance of fact, a lack of prejudice, problem solving, everything is fine. Like you all here as students are in this part, hopefully, with your creativity and able to learn without disturbances. All these other things are being taken care of, hopefully, when you're here. This is, by the way, something completely different, your student situation, from the student situation of our massive open online courses. Many of these people who study in the open online courses, they are just fighting to be here and to really get the basics of their life working, not because of their own fault, but because of the lack of the environment that they are in. So the structure and behavior in smart cities and responsive cities as related to this triangle that you saw, we tried to make here. This is from the EKD conference in Vienna just a few weeks ago. And this EKD conference, there was a talk on smart cities, which I found very interesting with the definition of smart cities. And it was shown how many smart cities there are already: 64 in the US, and 101 in Europe, and 53 in Asia, and 10 in Africa, and 13 in Australia, and 17 in South America, when she counted that. And they're very simple ways of making smart cities, or very primitive smart cities from the past, with devices like that. This is like a structure. Now it's closed. Nobody can get in or out. You open the door. That's behavior, and suddenly a flow of people and cars is possible, inside out. It's like a gate. It is a gate, actually. And you can make beautiful gates and ugly gates, but it is a form of controlling the flow and the behavior in a city. Probably in your mind you have more these examples that I showed before also, where you collect all the data that are existing in a city, or that you can measure in a city. Remember this lecture on data and measurements, very important, where you have a central coordination. Here, this is the example from Rio de Janeiro. And everything you can measure and visualize will appear on these screens, people watching these screens, people taking action if something is going wrong. But it's you could say, a detached from reality observation of those screens. And those screens and whatever is measured is just a representation of the real thing, where they are not. They are watching the screen, the screens and the monitors and the sensors watching reality. So these two, very simple flow, gate, open, close, with artistic means, made beautiful. And here, a very abstract, but also very efficient way to use data in a city. We come back to this talk on smart cities. The name of the presenter is Professor Emin Thompson, and the talk was on city is real-time. She was focusing on the real-time aspects of these smart cities. Real-time aspects is totally clear to you because you use real-time data all the time. But I thought it was interesting now to connect this real-time observation that she did in her research, that she found out in her research, to the previous ones that you saw, to the triangle and to the stocks and flows. And that is very interesting. So I don't know if you can read it here, but it's a bit rough. You see the mobile app types that exist. She listed the mobile app types that exist and then said what it is. So the first one is traffic and parking and travel-related apps. Then here we have cultural apps. Then we have reporting faults, problems to local authorities. Here's the environment, food safety, and health-related. This is social and tourism-related, this one. Then safety and security, directly related. And finally, I can't read. Can you read it? Business-related. Right. So if you take those, the existing apps, and link it to the triangle, you get this interesting picture. So the one at the very basic one, I think, which is traffic and parking related apps, very basic physical requirement to get from A to B, is here. Then there were 3 very strong apps related to safety. And then there, if use your imagination, those blue ones here related to esteem. But none of them is related to, let's say, self-actualization or love and belonging to these parts. So these are left out from the digital world, at least in these apps, in urban apps at the moment, which is either a business opportunity for you or it tells us that's too difficult to make an app about. So you can decide that on your own. But this is how you would relate now the structure and behavior of data and of data structures that you get from measuring a city to the triangle of the livability of a city. And if you go one step further, we can also link it to the stocks and flows. And here I just picked one, the transportation, because you see there's lots of transportation apps. And you see in the representation of the Future Cities Lab of this research project, you also find 2 of these stocks and flows directly related to mobility and transportation planning, and of course urban design strategies and resources also directly related to this very basic transportation and mobility concerns. All right, so I hope with that I could show you there is a strong link between what was defined as urban science in the past, as this combination of structure and behavior. We do find the structure and behavior again and again, no matter how you call the new approaches, you can always find and trace back these expressions and also the content of these expressions to these 2 basic properties, function and structure and behavior. There's differences between the countries, how much of these data they put into open source, accessible. So we see from the United States, they have 31%, according to her research, of all the urban-related data are open data. And we look at other countries like Finland, which has very renowned good cities, livable cities, smart cities supposedly, but they only have 4% of their data on the open market. So you cannot simply say if you have all the data open, you have more livable cities. It's not that easy. You have to look at all these numbers and measurements in conjunction, in an integrated way. But the benefits of these real-time cities, I just highlighted this one. Benefit is that it gets really citizen engagement. And this is where we want to get at with the citizen designs, because the citizen engagement is the most important thing in the present city and definitely in the future city. And this engagement of citizens with science is a difficult thing, because science, as we know it, the fundamental science, the basic science, are trying to explain, to reduce the complexity to a point where you clearly can reduce it to basic levels, to fundamental levels, and find out basic laws. However, if you involve citizens, people, hundreds, millions of people, that is very difficult to reduce it to a natural law. There is no natural law for a city. It's a different kind of object. It's not physics. It's not mathematics. Okay, now we are at this point, and I think we can explore a bit more this relation between the citizen and science and the citizen design science. We had at the chair a long discussion on how this expression citizen design science should be read or should be understood. Should it be read citizen design science? So should we make a science out of exploring how citizens design? That would be one way to look at. Or should we look at the design science as one historic development, design science, and then relate it to the citizens? You can do it either way. We give you a few options today, and you have to make up your own mind out of this in the future. But what is really underlying this is the observation that these people who wrote the Responsive Cities book, which I also showed before, and which relates to 2 slides back to this engagement of the citizens, is that what's really interesting is that people have said when they call in, use the old way of complaining, they feel like they are complaining. When they use mobile or these apps that you also saw before, they feel like they are helping. And this helping is a very human specificity that other things don't have. Nature doesn't help willingly somebody else or other parts of nature, at least as far as we know. So this is something that differentiates this from the other sciences. And we try to develop this new art or science of the sciences of the cities in our massive open online courses. You see generations back in this course here. These were the first people that we tried to work with to get this citizen design science defined and to work. And this here, for me, is always one of the most beautiful examples of citizen design science, because, well, maybe you say yourself, why do you think is this an example of citizen design science? What do you think? Make a wild proposal. Yeah?
Because it doesn't really influence the structure of the citizens as is. Because it's like something additional, but it doesn't destroy what already exists.
But how did it come into existence? How do you think, how did it start?
Because of the need of the people in the slums to get to the city.
Yeah.
Sorry, you can't hear it.
So the need of the people to get to the city was like why this came to existence. And it is constructed in a way such that the structure of the slum is not influenced by the new infrastructure.
That's a good explanation. Does anyone think there were architects involved in here? Does somebody know the architects of one of these buildings? Probably not. But it's also not architecture without architects, you know, because Le Corbusier, for example, he would be quite happy, I'm sure, if he would see some of these structures, because this goes It takes knowledge from architectural history, how you can build, what stands up, that Corbusier was refining more and more in modernism, and making very simple versions of that and putting it there. So it is an interaction between people's knowledge and their own design capability, but definitely in ordering and putting the streets or keeping the streets open, in connecting buildings and connecting them with electricity, of making sure that the water is collected here in these blue bars, and that the water, the used water, is going somewhere and not in the next person's house. This involves really design exploration and design decisions, and most likely this was done by the citizens themselves. Now this has always two meanings, and people ask me, oh, do you want that we all live in places like this? This is of course not the idea, but it shows that citizens themselves, they have much more knowledge about cities and how they work and how they fit together than we normally think. In places where we say citizens cannot do anything with cities, they can just vote yes or no, and all the rest is left to the experts. So these are the two poles that we are observing. Let's try a definition of the citizen design science. The design science exists in the 60s, as you just heard, and scientists tried to find description for the processes in the human brain when designers design. So that would very much go towards the design science, the science of how people design, of designing, the activity of designing. It was much more difficult than they first thought. Very similar to the beginnings of artificial intelligence, when they thought they could solve everything in a few months. And until today, there is no complete description of the human design process. Therefore, we want to propose citizen design science as a concept that adds the strength of thousands of citizens in terms of observation, human cognition, experience, and local knowledge to a scientific framework. So that's our approach. As a result, then, we describe citizen design science, the combination of citizen science and of design science. With citizen design science, citizens of all ages and backgrounds support scientists by either collecting or analyzing data and observations. Citizens working with scientific methods under the guidance of scientists collect data on birds and their habitat. This is the old examples. Or citizens interested in the functioning of the universe analyze millions of images sent by satellites observing outer space. I mentioned that before, just one floor above us. This is where Stravinsky is working with his citizen science projects, doing exactly that. In both cases, the internet is crucial. Millions of individual observations turn into a flow of data and information beneficial for science. We want to achieve something similar for design. Millions of individuals' observation turning into a rich flow of data and information to improve the planning and functioning of a city. So this is our definition of citizen design science. It's something very fluid. It has, of course, structure, which is the design process, but it has a lot of behavior also, and this behavior, this knowledge comes from the people participating in the process. Now, we have a real scientist here, Artem Chirkin, and Artem Chirkin will give us his view. He's not an architect, and he will give you his view of that.
Yes, thank you. So, first of all, I want to point that I came here from computer science, not an architect. So, I may have a bit shifted point of view related to these topics than designers and architects do. So, I found it convenient to understand citizen design science basing on urban design science and urban science. So if I liked this definition on urban science, where they say that it's knowledge about structure and behavior of urban system, but to regard this to citizen design science, I could just add that it is knowledge of structure and behavior not only urban system, but also a human design process as a part of it, as a process within this system. So, and this brings me to ideas which are quite popular now in general in internet because of many new possibilities and computational technologies which are used everywhere. So one of these are recommender systems, which you probably, most of you, used some or all of these services on top. For example, Last.fm or Pandora Radio use special complicated algorithms to track all your actions, like whether you like song or dislike song. They then track this and recommend you another song based on what other people like, which also liked the songs you like, or based on just songs similar to that. The same with other services like items on Amazon or people and communities on Facebook or LinkedIn. So this brings us technologies for data analysis, for, they call it collaborative filtering or content-based filtering, implicit data collection. Other point is machine-learned ranking, which is also used everywhere in search engines. For example, when you click on a result of search in Google, for example, there is no surprise that your action is recorded, and then this gives information to a program, to an algorithm in Google, that, for example, if you click third link, then it says that it's better suits your question than first two links. And this gives information to machine learning algorithm to decide then how questions are related to links and how to rank the links better. So if we put this together and connect it to generative design, to all tools we have here in urban design, we could create a simplified tool, design tool, which would provide help to designers or even to ordinary people. If we make it simple enough, we can just give it out for citizens and ask them what they want to improve, and then get the result and process this all together and help to design better things. Could we go next? Yes. So here we come to the idea of my research as design and feedback loop, which is highly interactive and natural for a person. In this case here you have a designer, but if we make this tool simple enough, this also can be just any citizen, or it can be student in our MOOC courses, which we are going to do the application. So in this loop, you can spot at least two places where a user implicitly or explicitly sends the data to algorithm to give his experience, knowledge, or opinion. One is easy, is when a designer just makes a new design proposal and submits it to the program, so it can analyze it somehow. Another spot is here, when designer just chooses what program have to show to him. So in this loop, designer first does some design, then he expects program to suggest some alternatives based on past experience, and it generates a couple alternatives, not one. And then if user selects only one of these, it already gives an understanding to a program that this design is better than another one, and this gives additional information, just like in search engines. And for this, for sure, we can apply all these techniques which are available now in different other fields than urban design. So this is my understanding of this topic.
Okay, thank you. So I think we should have some questions left for understanding, better understanding, or for debating or relating that from your side. Now here's somebody who is coming from another field into urban design and as a very visible part develops programs that could be used to support this citizen design process. Do you think that's feasible? We had a big discussion this morning already, so I want to spare my questions, but maybe you have a question to that. Miro. Yes.
It should be quite similar to the way how Google is organizing, for instance, the page rank system or something like this. You know?
Kind of, yes.
But what do you see? Is there a kind of a different, a kind of a step forward from this, or you are taking this as a kind of an existing framework and then applying it on cities?
Well, there are a lot of technical details about this, especially which regard to how we represent in program actual design. It's not that simple. When if you see it in CAD system, it's just geometry you can manipulate with. But program doesn't understand what happens there actually. It just sees the geometry and it doesn't know about what is your intention when you do this. So this is an open question how to represent it so that program understands it correctly and convert it into right understanding of your design intentions. And there is research literature how to do this better. There is one interesting example of this ranking system is done by MIT research group. It's called Street Score. It ranks streets according to their perceived safety, just by using Google Street Images. So they asked first a number of people, like thousands of people, to watch an internet couple of pictures of different locations and say which looks for you safer. And that's all they asked. So they got this huge amount of data and constructed a ranking amongst these images, which one looks safest according to people votes, and which one looks really dangerous according to people votes. And then they used specific machine learning algorithms, computer vision algorithms to understand what happens on scene, like which colors are there, which objects are there, and then they converted into vector representation, mathematical representation, and make another machine learning algorithm which can just train using human data and then rank on their own these street views. So now there is a site, you can Google it, Street Score, and on this site you could just click on any place on the map and they show like a rating how safe this place is, just according to image of the place.
So that is the belief, or it's a belief that just from looking at these images you can draw a conclusion if it's safe or not, without knowing the place, without knowing anything about the structure of this society or whatever. And that, of course, is the big debate between the big data believers and the architects and designers who think this is not possible or this should not be possible. And that's exactly the point of this or today's lecture, to get you thinking about this citizen design science. If design is a science, if city design is a science, why do you need people? They can only disturb the science. They can only disturb the fundamental great findings that the scientists will have. But if you really take them into account, which you have to, because there is no city without people, then the science doesn't become as clear or as easy. And then you have to depersonalize the city, which is one example that you just gave. So in between, somewhere, we have to find a path. And you can be sure, any one of you going into a city government later, or going into a company having to do with cities, or city planning, or regional planning, or urban design, you will be confronted more and more with this necessary influence by the citizens. And so that's what we want you to understand, how and that citizens influence this design. Okay, as I was afraid of, it's not enough time to go into the other example. We will do that next Monday when we go into the complex system. Thank you very much, Artem, and I hope it will work out as you plan, especially with your PhD. Let's see. So don't close your eyes. Don't look through that. It goes very quickly. This is what you would have seen, and that you will see with explanation. Close your eyes. Don't close your eyes. I tell you when to open them again. The machine is too slow. It cannot handle all these bits and bytes. You know, it's terrible. Now you see too much. I think I almost killed it. Okay, now, conclusions. Conclusions. The urban science has been an active area of research since the 1960s. And what we just discussed in the end, from the very beginning, there was a mismatch between the top-down decisions, this belief, this somehow naive belief that you can plan cities as scientific objects, and the capability of the population to react appropriately. And the population did not accept those plans in many, many cases. And that ended up in violence, in misuse, in falling down, and so on. And every planning process which is purely based on scientific means is exposed to that. And therefore, we propose the citizen design science to combine the advantages of evidence-based long-term planning. Don't throw it away. There are things that we can find out scientifically from past cities and past experiences, like the people in the favelas use technologies of building a house which work. They don't reinvent it all the time. So this is the evidence-based long-term planning and design capabilities and the experiences of cities. So this combination we want to see as citizen design science, and that hopefully will improve the existing cities and help us to design almost perfect new cities. So thank you very much for your attention. I see you next week. I have to go to Singapore tonight. We'll start our big new project, the Responsive Cities project. We'll have a big workshop there and many other events. And hopefully we are back on next Monday. And then we talk about complex systems, cities as complex systems. Thank you very much.